Good evening. My name is Zoratti. I'm the Sales Consulting Manager for MySQL at Oracle in EMEA. So my job is related to the, let's say, to help in defining the right architectures with MySQL for Oracle and MySQL customers, of course, covering EMEA with myself and my team. The presentation today is on Oracle and MySQL combined together and working together to get the best, of course, from both databases. I understand it's 5 p.m., so you may be pretty tired. But I will start with a disclaimer and with 3 questions. First one is, have you ever seen this slide before? Second question is, who's using Oracle, let's say from 9, then 10, 11 now? Okay. And who's using MySQL? Okay, good. So, we assume that you already know Oracle, basically, and you may know or not know MySQL, and you want to understand how it's possible to integrate and how it's possible to work together. So the agenda is here. So I will just give you a quick introduction to MySQL in terms of product and why it's so well known and so important. I will cover a little bit the architecture and MySQL Enterprise. The slides in there are quite important to understand then the next steps, meaning the use of MySQL in online applications and the use of MySQL for some specific applications, so you will understand when it makes sense to use MySQL. And finally, we will have a final part related to the integration between MySQL and If you have any question, feel free to stop me at any time. I'm happy to take questions during the presentation, or perhaps we can take it, if it's not completely relevant, we can take it after later. Right. So first introduction, you have already seen this slide, of course, related to the stack, the complete stack that Oracle has available in the, let's say, the traditional set of products. Well, basically, there is a similar one, but slightly different. I made this, so you can see it's not the best one from a graphical perspective, but it's an open source stack, and that's, again, with Oracle products or Oracle contribution to some products. So from the Oracle Enterprise Linux that we have seen also in the keynote yesterday and today, then of course we have MySQL as a database, and then going up Glassfish as our application server, and all contribution to the Apache projects, and then the modules and what you can have with Eclipse and Ease, and going up of course to the applications that are, generally speaking, the open source applications. Now, MySQL today, just to give you an idea of the history and the present of MySQL, it's a database that's been in development for, quite a long time now, 15 years. It's been acquired. It was owned by a company called MySQL, and then the company's been acquired in 2008 by Sun Microsystems, and then, of course, with the acquisition of Sun Microsystems, now part of Oracle. We say it's the leading open source database for online applications. We may even say it's the leading database for online applications, and you'll understand why I'm saying this in a minute. We count more than 12 million installations in terms of server installations. It's an estimation because being an open source product, of course, we can't count all the installations there. And the interesting aspect from our website, from the MySQL website, is that we count more than 70,000 downloads each day, downloads of server, connectors, etc. So it's, of course, very well known. And the last point is another important point, the fact that we're always focused on performance, on reliability and ease of use, and you will see these 3 elements in the next slides, and you will see why they are so important. Just a brief overview of our customers. Of course, it's just a subset of the most important customers in web, our OEM customers, for hosting and SaaS, and telecommunications sector, and enterprise 2.0. But the main point for us, the main environment and market we are in is probably identified by this slide. These are the top 20 websites based on the ranking on Alexa. And if you can see that 16 of the 10 most important websites run with MySQL. So we can say pretty much the same thing as you may have seen all the advertising of the top 20 of the 20 most important companies running with Oracle, that we can say the same for MySQL. So the ones with the white font are the ones running MySQL as a main front end, as a main database for their front end applications. You can find MySQL in 3 different flavors. You can find the community server, which is the one you can go and download now from dev.mysql.com. And that's the community engine, the community server. It's under GPL. It has no maintenance, no support, no ASV certification. So basically, you can download it, you can use it as you like, of course. You may submit a bug if you find a bug, but we cannot guarantee we're taking care of the bug. We may not. It depends, of course, on our engineering and tech support team. For customers and for mission-critical applications, we recommend the use of Enterprise GPL version. So it's still under GPL. It comes with services attached and with tools that are specifically designed to manage enterprise applications. And in between, you have a commercial license that is used usually as an OEM solution. We call it MySQL Embedded Server. It can be bundled or it can be deeply embedded into an OEM application. We are talking about the same software in terms of server. The server is exactly the same source code. There is no difference. There are different builds, however, and different licenses. Now let's see. Let's talk a little bit about the architecture of MySQL. I asked before if you have already seen this slide. Let's see if I can find it. So we call this architecture the pluggable storage engine architecture, and the reason is because, of course, it's based on pluggable storage engines, and the storage engines are the modules down here. But in general, the architecture is very similar to any other database server, I would say, again, from a generic perspective, where you have the typical client connections. You have a connection pool that is a module responsible for authentication. It's a multi-threaded environment where you can actually define for each thread a user connection, and you can reuse the cache elements. You can use define some limits on the connections, on the amount of memory you can use for each connection, and so on. The query, of course, starts from the connector. You send the query to the server, and then it goes through these other modules, the SQL interface, the parser that has to identify the right privileges, etc. And of course, there is an optimizer as any modern relational database, and some caches. So no difference between MySQL and other relational databases. What is really different is these are down here, where you have some specialized modules called storage engines, and they are pluggable. You can plug and unplug these engines depending on what you need. So you may have a lightweight version of MySQL where you have only one of the storage engines because you don't need all of them, and you want to reduce really the amount of memory used. I'm not going to explain and give you information on all of them, unless you're interested. We can talk about that later. But I would say the most important ones are these ones here. The standard storage engine up to 5.1. With 5.5 we change it as a standard with being InnoDB, but the standard at the moment is MyISM. MyISM, as the name says, of course, it's a pretty much like a nice engine working on a typical sequential files, indexed sequential files. It's a very lightweight storage engine. It's mainly used for read-intensive applications, and it's a typical engine with no referential integrity and with table locking when you write data. So again, very similar to a sequential file where you need access, of course, and you have to lock the whole file. If you need or you're looking for something more typically relational, then you can use InnoDB as a storage engine. And InnoDB comes with all that you may expect from a typical relational database with ACID compliance, referential integrity, and so on. And then there are many others, like the archive engine that saves your data in compressed format. It's mainly used for logging data. You can write this data, but you cannot delete it. Being a log, of course, it doesn't make sense to remove information. Or you can use the memory engine, which is an in-memory storage engine, very fast, generally used for temporary data. So you can see you have many choices. And partners and the community and customers, they create or they may create their own storage engines. There are many others out there, like the columnar engines for some data warehousing applications. There are some engines that are used for specific application where they capture data, they need to log lots of data, and so the insert is the most important aspect. And then they can, of course, be analyzed and executed offline. Another important element of MySQL and the MySQL technology is replication. Replication is built in. It comes with a MySQL server, and it's a typical master-slave replication. Again, up to 5.1, which is the current GA version, replication is asynchronous. So when you write on the master, you commit a transaction on your master. You don't wait for the transactions to be propagated on the slaves. You immediately have an acknowledgement of that, of your commit. So it's pretty fast. It's not meant to be 100% safe. It's meant to be fast and then scalable and useful for more scalability, specifically in read-intensive environments. And it's so easy to configure. It's really really simple. It takes 1 minute or so to implement it. You have a statement-based replication or row-based replication, meaning that you can replicate the whole statement, and then the statement will be executed on a slave or more slaves. Or you can use a row-based replication to replicate every single row. Of course, we have pros and cons for both. With 5.5, with the new version, which is release candidate now, you have what we call semi-synchronous replication, meaning that your transaction, when you commit the transaction, it must be synced on at least one of the slaves available to get the acknowledgement of this transaction. So of course, in that case, you have something that is safe in terms of data corruption or data loss in case of fault. Just briefly, the way it works is based on some log files that we call binary logs, just to confuse you a little bit more. And that's on the master. The slave pulls the data from the binary log, it stores it into a relay log, and then it executes everything that is in the relay log. So the slave then is updating this information. Another important element of this of the MySQL technology is called MySQL cluster, but specifically and technically, MySQL cluster is a storage engine called NDB, Network Database. Actually, the name cluster is quite misleading because you may think about a cluster of servers like OS clustering. That's completely different. It's a share nothing solution where you have your database server on top and you have some data nodes, and these are like Unix or Linux daemons, just to make it simple. And they are responsible for storing and retrieving the data. And you can create a network of these nodes all over your private network. And of course, it must be fast because this data, as I said, is sparse on all your network. And the scalability is achieved here in terms of you can increase the number of nodes on the front-end nodes, the nodes up there, all the data nodes down here if you need more power and bandwidth in terms of read and write data through these nodes. Or another way to view the NDB storage engine is this one here, where you have the MySQL server and you have data nodes under here. You can also skip the use of the server itself, and you can go and access this data through some C APIs or C++ APIs or Java and so on. And that's the preferred way to use MySQL cluster for telco solutions, telco applications. Your mobile phone will probably identify, your mobile operator will probably identify the position of your mobile phone using MySQL cluster. That's what they do probably, I would say, 90% of the mobile operators worldwide. And it gives you an idea on the main use of this technology. It's very, very efficient and widely used for a high volume of small transactions. And by the way, it's fully transactional with distributed transactions among all these elements here that may be SQL or non-SQL based. So just to summarize, in this slide you can see what we have on MySQL 5, on 5.0, on 5.1, which is the GA version now, and on 5.5, which is release candidate. It's a summary of a MySQL server, the MySQL cluster, and some connectors, some client products, and so on. So in 5.0, we released 5.0 in 2005. We finally added store procedures. We added triggers and view to MySQL. And the idea is to release versions with new features only when these features are absolutely necessary. We don't want to add features just to fight a war against other databases for the best features available. That's not the idea. The idea is to keep everything simple and just add what you really, really need. So at that point in 2005, it made sense actually to have triggers and views, and that's what we have done. We have added that. We also added server cursors. We didn't have them before, and information schema, and so on. So you can see all the features, all the subset of these, the most important ones. In 5.1, we added role-based applications. We added, and we have improved. We added partitioning. We have improved the full text indexing, etc. And now with 5.5, we are mainly focused on performance. But we have also added semi-synchronous notification, as I mentioned before, some extra modules for diagnostic and for the enterprise. We have MySQL cluster on Windows and so on. Another important element, again, to understand the use of MySQL is to understand how highly available it can be. And it can be highly available based on some other technologies that are directly related to MySQL, and where we certify MySQL with the use of these products. One of them is DRDB. DRDB stands for Distributed Replicated Block Device, which is a typical solution, Linux solution, where you can replicate data from one node to another at a block level. So when you commit your transaction, you physically write on disk, and when you write on disk, this transaction is automatically replicated from DRDB from one node to another. So in case of fault, you can start a passive node, the node becomes active, and you have everything available here. You don't have data loss. Of course, you have a failover time, which is quite important to consider. But the main point here is that you don't have any loss of data. You can, of course, use the typical shared storage cluster, which is similar to the Datacenter solution, if you want, where you have a typical active passive environment with the shared storage, and again, in case of fault of one of these servers, you can switch over to the other. We don't have a solution which is active-active, like Oracle RAG, for example. We may have something we can claim is active-active, which it is actually active-active, which is a MySQL cluster, but it's a completely different architecture. So the technology is different, it has different objectives, and it's used in a completely different way. So there are two technologies Another important technology that is part of MySQL and the MySQL environment is the distributed caching, named Memcache. So Memcache, it's not a MySQL or an Oracle technology, but pretty much everywhere where you can find an extensive use of MySQL, you will find Memcache. So Memcache is a high-performance distributed memory system, where basically you use Memcache to distribute your elements, your data on any available server. And the main objective here is to reduce the number of database servers underneath. So with the use of Memcache, you basically speed up your solution, your application, and you have a lower number of servers in your database environment. Now, very briefly, I will give you an overview of MySQL Enterprise. MySQL Enterprise, as I mentioned before, is the solution we provide for the enterprise for our customers. It comes with a price tag, as I said. It's opposite to the MySQL Community Edition, which of course you can use for free. But in this case, you have the database server, which is updated every month with a rapid monthly update, or every quarter with service packs. You have some monitoring tools, and they are probably one of the most important aspects related to the use of MySQL Enterprise. And of course, you have support attached, what we call, well, the typical support, and what we call also consultative help, which is something quite unusual for Oracle tech support, because in this case, we provide support, or mainly we can say consulting over the phone or over emails, so you can actually call tech support to ask questions regarding the optimization of queries or your configuration and so on. I mentioned the monitoring tools. The main tool is called MySQL Enterprise Monitor. And in this case, we have a consolidated view of all your servers on a single environment, and from here you can basically control the whole set of your servers. Again, it's quite important to use a product like this because, generally speaking, a MySQL environment has hundreds, if not hundreds, at least tens of different instances, and it's quite important to control all of them. It's quite rare to find only one or two MySQL instances. So the result is that you have a common monitoring server here based on a MySQL repository that collects the data and stores everything into this database. On your servers, you just install a small agent. It's a quite small agent that you install, and it will, of course, it will collect all the information and send them to the service manager. This is just an overview of the dashboard, the first page on the dashboard, where you can see the heap chart and check if there is something you need to take care of. You have the list of the servers, some graphs that are related to the server or all the servers that you have identified there, and some critical events that are happening. And of course, you can see the tabs from where you can identify specific events, analyze more graphs, and so on. You can control the events with, there are more than 140 different advisors and alerts you can create, and about 40 graphs. Okay, there are quite many. So you have a complete control of your environment. Again, related to the use of the Enterprise Monitor, there's another tool which is quite important called Query Analyzer. So in this case, if you identify a problem, you can review the queries that are available here, and you can actually check the queries that have been executed at a specific point in time. So you can drag and drop a time frame or time window up there. Perhaps you have found a spike there, and you can check which kind of queries have been executed. And then you can analyze them, checking the query plan that has been executed. Very briefly, the whole query analyzer works with, again, with a proxy server in between the application server and database, or it can also work directly with a plugin on the connectors. On one of the connectors we have the connector J, which is a JUC connector for the .NET, and we have now new connectors coming up, the C and C++ connector and PHP connector with the same features. The difference, of course, is here you have less overhead, but you have to change the connector at a client level. In the other case, you have of course, a middle layer that can give you an overhead, but you don't touch the client. This. Right, and again, I would say the MySQL server, of course, it's a standard relational database. It can be used in many environments. But the most important ones, as you have seen the slide that I presented with the 16 of the 20 of the top 20 websites run with MySQL, of course, is the use of Web-aligned applications. Why is it so interesting for an application, and how you can use MySQL? Well, I have a few slides here, and let's see if I can help you in understanding this. The main point is scalability. So if we identify the typical vertical versus horizontal scalability, we are basically here. We've always been here, and we will always be. So there is no reason for us to work in an environment where we can have the large S&P box, because we cannot even take advantage of all the resources available. We are very much a lightweight environment that is happy to run in a physical or virtualized small box, and of course take advantage from all the resources available in this box. So for example, when you have some read-intensive applications, and you can take here any kind of interesting application you can find on the web, the idea is that your application servers can rely on reputation to write data on the master, and then to read data from all the servers available as a slave. And now here I have 4, but let's say it's not unusual to find tens, if not hundreds, of slave servers connected to one or only a few masters. And this master can be fed in some way by your application or by a content management system, and then you can make this available for your customers or your users. So in a again, read-intensive application, you can even have some relay servers, so you can have, as I said, hundreds of slaves down here, and you can redirect your queries on all these slaves. So if you take, let's say, Wikipedia, for example, where you have, of course, lots of reads and very few writes, you can see that the use of this environment is quite perfect for this kind of environment. But it's not just read-only. I mean, the online world is not read-only or just read-only. So you have also some write-intensive applications. And for write-intensive applications, well, there is no magic, not with MySQL or not with any other database. So the idea here is to handle multiple connections. So you can have a set of connections for authentication, a set of connections for session management, logging, etc. And you can read and you can distribute this workload on multiple servers. So you can start with a single instance, and you can have everything on a single instance first, and then the more workload you add, and you can basically distribute this workload on multiple servers. Ideally, you will not have well, you will not need a distributed transaction because you may identify that well, authentication will be executed only on one server, or your application data will be only on some other servers. But that, again, that's just a generic thought on how you can actually scale on write-intensive applications. Another important aspect to consider is the use of these connections related to the persistency of your data, on low persistency or high persistency. And this is very much related to the use of different storage engines. And again, I have a couple of slides that can help you in understanding this. So the ultimate solution for online application is the use of sharding. And to give you an idea of how sharding works, well, basically, you have your set of application servers on top, up there, and you identify a shard given a specific application usage as an element like this, like one master or a few masters and some slaves. So your shard will be responsible for using and delivering information related to a specific set of data. And for example, if you are managing some user information, you can identify a user on one of these shards, and for example, if you have like 5 shards here, you can basically spread the workload of all your requests for different users on these shards. Some of your data will be replicated and will be duplicated on multiple servers here, and some other data will be unique within the shard. So with the use of replication and the duplication of your data, basically you can spread the workload and you can actually reach millions of transactions per second just with the use of the scale-out solution like this. So again, just to wrap it up, in a typical front-end database infrastructure, you have your application servers up there, and you may use, for example, some servers for authorization and profiling, and the storage engine that I mentioned before, the NDB, is quite useful for this because it provides high availability, high performance. You can easily manage hundreds of thousands of transactions per second with 2 or 4 small boxes, so it would be perfect in that case. If you need to manage like your sessions, you have typical baskets or cards or the current configuration of your environment when you are logged in. Again, the NDB and perhaps another NDB set of servers can handle easily this kind of data. And when you have a typical transactional application data, so for example, orders, invoices, or your wish list, let's think for a moment on a typical e-commerce website where you have various information. Well, they all work in pretty well within a DB and again in a sharding approach. So you can scale pretty much indefinitely with this environment. Your non-transactional data may stay on MyISAM, and here you can have catalogs on some recommendations and reviews or comments related to a product. So you can search by text, you can identify some of the products searching data on this environment, which is to some extent more specifically designed to provide information quickly and in a faster way than the other storage engines. And again, if you need to log your data with a clickstream for clickstream analysis that you will use later, you can use the archive storage engine. So basically, all your information about the click-through or a clickstream analysis may go on an archive engine. And then you can take this engine, you can basically pull out the data and you can analyze it in a different environment. And all of these will have, generally speaking, a distributed caching on top. As I mentioned, memcached before is the most important one that is being used. So that said, okay, I spent, I would say, the first part of the presentation to give you an idea of the technology around MySQL. Okay, let's see when it makes sense to use this technology, when it makes sense to use MySQL compared to the use of Oracle or any other database. Again, these are just guidelines. They may be relevant or non-relevant for you. You may, of course, you will decide. So, assuming that you are already an Oracle user, or let's say a typical user of commercial databases like SQL Server or DB2, etc. Here are some aspects. When you work with the client connectors, well, with MySQL, we have pretty much connectors for, I would say, all the main operating environments and development environments. Of course, we run very well on Linux and on Windows, but we have client connectors for any other environment you may think about. And the same is for the languages or frameworks or different modules we can find. In terms of security, we don't have an extended security mechanism. So if you are familiar with the typical external authentication, well, we don't have it at the moment. It's in the roadmap, but it's not available in the GA versions yet. So again, this may be a showstopper, or it may be something that is not relevant for your application that would be good enough, but you have to consider it. In terms of connections, so let's move from the client down to the server. We have a typical online approach. It's very easy to connect and disconnect from a database, as you may expect in a typical online environment. You click on a page, and you need to get data to fill the page, and then you have to leave the database, so you disconnect and you show the information to the user. It may not be optimal. You may say, why don't we use maybe a connection pool and some permanent connections? And of course you can. They are great, but they are not required. I mean, the time you need to have connect and disconnect is minimal compared to other databases where you have a quite heavy traffic and takes some time to have a connection established. And of course, that is very much related to the typical use in the LAMP stack with PHP and other languages where you really need to have this disconnect with. So that may be quite important for you if you consider to migrate one application from one side to the other. Whether you are using MySQL now and you have a quick connect, disconnect, and you want to replace MySQL with Oracle, for example, with Oracle DB, or the other way. In terms of language, the typical DDL is very standard. Of course, we have our own dialect, but we have all the standard ANSI available, and you will not find any specific surprise here. The use of the alter table, and typically, when you want to add or drop indexes and so on, is not available online, meaning that you cannot just alter a table and use the table in read-write mode as usual. Or you can do it with cluster, with MySQL cluster and the NDB storage engine, but not with all the other storage engines. So again, that's something fairly specific. You have to be careful if you are used to just run an alter table online. And generally speaking, again, as a guideline, MySQL replication comes handy here because it's used for some planned downtime. If you schedule to do an upgrade, usually you just switch over to a replicated environment, and then you switch back, and you have some modules, some triggers, or some various elements that can help you in keeping everything consistent on both sides. For the typical DML, in this case again, nothing unusual. Just some ideas on the fact that if you want to run a simple test and see, how performant is MySQL compared to other databases, there are things like, for example, multiple inserts and replace that if you're not aware of, you may say, oh, but that's incredibly slow. But in reality, it's just the way it's implemented. You can have like a multiple set of data that is inserted in a batch mode, and you can insert like thousands of rows in one single statement. Or the replace basically will do an insert or an update depending on the fact that the row is available or not. What you may identify as hints for us are rules, meaning that you actually say, I want to use the index, or I don't want to use the index, or I want to use the index only if it's available. And again, I mean, you have to consider this in case you are using hints, of course, in your previous Store procedures and store routines. We have a very basic store procedure language, and well, I would say a migration from a PLSQL, heavy PLSQL environment to MySQL would be interesting. Well, the main point here is that we do not rely on store procedure for heavy activities. We basically use it for saving some network hops if we have some, specific elements that make sense to have within the server. But it's typical to have the classic use of some PHP or some scripting modules that interact directly with the typical client-server environment with MySQL, more than the use of store procedures. There is one important aspect related to MySQL that is not well known. It's the use of user-defined functions. These are functions that are written in a typical 3GL, in C or in any other language, and they are compiled and they can be added to the server. And they are extremely efficient, meaning that they become part of the server. You can extend the server as much as you want, and then you can call that that function from your SQL statement. The difference is, of course, on the way it's been executed and the fact that you have an efficient language there, but it's also more complicated to create a UDF. Referential integrity is available within a DB. The question is, do you always need it? If the answer is yes, well, you have to use InnoDB, otherwise you will not have it. And you shouldn't mix tables. Like you may have an InnoDB table, and you may have a MyISAM table. Okay, referential integrity, of course, goes away, and so the asset compliance, etc. So you should be very careful with that. But sometimes you don't really need referential integrity, so you may use other storage. Again, the storage engines is the main element here. There are many options. You should choose the right one, the right for the job, of course, and that is really the main point. That said, I would say the majority of the applications run within InnoDB, and again, it makes sense. But there are also many other applications that still run with MyISAM and NDB. The cluster engine is another very famous and very important. As I mentioned, high availability. You have maybe different solutions, but again, there are highly available solutions. And the optimal solution is usually based on a mix of technologies. Okay, so you don't use only one technology. You don't use only MySQL replication. You may use several technologies, like MySQL replication with DRDB or MySQL replication with an OS clustering, for example. For disaster recovery and geographical replication, well, MySQL replication becomes quite perfect, I would say. In terms of a typical master-slave, or you have also master-master solutions. We don't have conflict resolution, with the exception of the NDB storage engine, again. But again, in general, they are. It's quite well known as a solution, even without the use of conflict resolutions. Extended features. The main point is keep it simple. If you really need extended features like some super XML or text search or spatial features, well, maybe MySQL is not the right database for you. It does have these features, but they are, I would call them basic. Okay, so you should really look at them and see if you have all you need. Otherwise, you should really consider something different. So. Just to summarize with a couple of slides, some myths here on the fact that we don't have referential integrity, we don't have performance, we don't have scalability, we don't have availability. That's something I would say not really true. You can check the number of transactions per second we can perform in read or in write. What I showed you in terms of technology, well, the fact that you need sharding, of course, if you are like a Facebook, then you do need sharding no matter what, no matter if you have the fastest database in the world and the fastest machine in the world. Yesterday in the keynote, Larry said, you need 2 servers. Okay, at least 2, not 1, okay, even for Facebook. And anyway, only for the web servers, we did not mention the database servers and the other modules and other service units. Scalability, performance, and high availability, as I mentioned. The reality is we have basic SQL features, so you have to be very careful with that. We have a limited procedural language and limited extensions to the standard SQL. Indexing is, well, limited to the, I would say, the basic ones, so we don't have bitmap indexes, for example. We don't have a rank-like architecture, so if you are really looking for an all-active solution, we don't have it, or it's different, at least. So why should you use MySQL? And we should use it for online applications, as I said. That would be probably a good choice as being and in the LAMP stack, if you, of course, you're using or considering to use PHP, Python, or Ruby. It's quite, of course, quite popular and interesting. It's the most common database on the internet, of course, and basically the default backend for lots and lots of online environments. It's great for data marts. You need like something quick and dirty. You can download data and then you need to analyze it. Okay, why don't you take or you create a virtualized machine, or you take a small box. You load your data in MyISAM because it's easy. Create, use, and remove. You load all your data and it's quite fast also in terms of bulk loads and in terms of analysis. And basically all the main commercial and open source BI and reporting tools are certified and they run with MySQL. And again, it's great as an embedded database. It's quite lightweight. It can have a very small footprint, so you can run it on very small devices. But on the other hand, it can also be on a relatively large installation. So it has a quite wide range here. And it's simple to bundle into your application, or it can be even deeply embedded, so it can be part of the application process. So you don't need to have an external process to execute. Well, you should not use it definitely for ERP solutions, where there is no certification at all, no compatibility with MySQL. We are missing some features that are really required here, and it's not that scalable for a typical SAP environment. And it's definitely not a system useful for data or for large data warehouses and business intelligence solutions. We have a pretty good optimizer, but the sub-query optimization is not that great, and you may expect, of course, some very important and interesting queries in a typical BI environment. And some of the features related to the indexing, the partitioning. We do have partitioning, but again, you cannot move partitions here and there, for example, and that's quite important in a data warehousing environment. So again, you have to be quite careful. We don't have parallel queries. So again, that's another important point if you have a serious data warehouse. Right. So the last part of my presentation is related to the integration of Oracle and MySQL. Let's see how you can actually make them work together. First of all, let's identify some of the aspects related to the integration. One is the application integration, where of course we may have some information and some services that need to exchange information, and the fact that they need maybe to share this information. On the system side, in terms of systems integration, co-location and coexistence between different instances may be an option. The way to administer different systems and different databases from the same interface is another important element, and the monitoring, of course. And then finally, the data integration. So the integration of your data using data transfer and data exchange or replication, or data sharing, so direct sharing of your data. Again, these are guidelines. They may be relevant, or maybe they can really be implemented or used in your environment. So in terms of application integration, the main element here in terms of information exchange is commonly used, of course, through some messaging systems. So you send messages from one server to another, and you have application modules that then they will get or feed the database. And there may be some internal components that can be executed in C or C++, Python, etc. But I mentioned the UDF, the user-defined functions before, and again, they come pretty handy when you have like these kind of modules. Building a user-defined function is relatively simple, of course, if you know a basic standard language, and it can be really fast and straightforward in this kind of environment. Another way to integrate from an application perspective is the use of a distributed mechanism. So you can basically share the same cache. And again, since MySQL is very much related to Memcache, you can use at an application level, you can use Memcache to store data that goes and that comes from different databases, from Oracle or from MySQL. And you can even add Memcache okay, you can use them as client environments, so you can add them as plugin as database functions, for example. This is an example. So from MySQL, for example, you can just do a select, and you can set or get data within the MySQL server and directly to Memcache. And you can do the same with Oracle in various ways. So you can use Java, you can use an extended element that can actually give you access through your D2C connector, although of course here we have a quite a performance issue. And the way you identify the query can be simply using a hash algorithm and identifying perhaps a long query with a single element, and then you can use this single element to execute data from and retrieve data from MySQL on one side and Oracle on the other side. So with a distributed mechanism, you may have multiple applications up there, so the one running with Oracle and the other one running with MySQL. You can retrieve your data and store it on the Memcache cluster, and you can do the same with MySQL. In terms of systems integration, when you have a co-location of different instances, first of all, there are no problems, generally speaking, apart from, of course, resource contention you may have if you have a quite heavy load on these servers. That you can exchange information using files, and again, there are different mechanisms here, both from Oracle and from MySQL. So you can basically extract your data and store it into a file of different formats, and they are all available and can be loaded or at least used from the database. So for example, even with MySQL, you can have a storage engine which is called a CSV storage engine. So you can see a CSV file as a normal table, and you can select or insert data into that table. There is a commitment from Oracle in providing the system monitoring and system tools you can or you may want to use, like Oracle Enterprise Manager, Oracle Vault, and Oracle Secure Backup. And basically these tools with integration of MySQL are under development at the moment, and they will be available in the next calendar year. And there is also a plugin for Oracle Enterprise Manager that is available now. So you can basically manage MySQL from Oracle Enterprise Manager directly. You will see probably the slides and on websites, and you may basically use these URLs to check the content. So if you can't wait for the enterprise manager to be integrated, MySQL to be integrated into OEM, you can already use this at the moment. And of course, you still have the enterprise monitor, the MySQL enterprise monitor, and that will stay. It's not going away because there are customers who are using MySQL only solution. Now, in terms of data integration, let's start from the very basic, from batch transfer. So, with the use of Oracle Data Integrator or any other tool, you can actually construct and build, a sort of file transfer of bulk loads. The use of the SQL Plus and the SQL Loader to extract or to load data is very similar in MySQL with the use of MySQL dump and MySQL import. Pretty much the same thing, and they are compatible, so you can load data or unload data in the same way. As I mentioned before, CSV files can be from both sides accessed as a table. And then there are some partners. One of the most important ones for us is the Informatica. It's one of the most important for the MySQL ecosystem, where they have a product suite that is certified to run with MySQL and Oracle. Another aspect, again, for integration is real-time replication. So you may use replication between Oracle and MySQL in many ways. One is, of course, the use of one of our products, Oracle Golden Gate. So with Golden Gate, you have basically a real-time change data capture from Oracle to MySQL. Okay, that is available. We don't have the other way around yet. We are working on that, and it will be available in the future. Okay. If you need to integrate Oracle and MySQL in a bidirectional way, you can use a typical ETL structure. So you have these bulk loads, and you can, of course, again use Golden Gate for that, and you can use it on the three most typical environments. There is a solution out there from a third party, which is again a partner of MySQL, called Kit Software. And they have a product called dbMoto that provides real-time CDC bidirectionally. Okay. Now, the limitation here is it's a Windows-only application. Okay. It works by capturing data from both log files, so you can actually identify the logs on Oracle and the ones on MySQL, and then they are replicated on the other side. Okay. And there are different options for what they call refresh, mirroring, and synchronization with using dbMoto. So that's a quite I would say quite good solution. That if you need the bidirectional transfer, it's of course pretty good. The final point on the integration is the use of real-time data and real-time data connection. So you do not want to replicate your data, you want to access the data on the other database. And okay, it may be fast, it may be real-time, but it may be very difficult to scale, especially with like response time of only a few milliseconds. Then these things become quite difficult to achieve. But the idea is to use Oracle heterogeneous services from one side, so you can access MySQL from the Oracle side using OHS. And from MySQL, you can use the user-defined functions. So you can just pass in a function a specific query that it will identify your connection, and then it will basically execute the statement in the MySQL in the Oracle instance, and then get you the result. Or as an element that must be, of course, carefully evaluated, because at the end of the day, this is just a cache, and you may lose your data in a cache because it can be evicted. You can use main cache for sharing, and that can be, again, pretty much in real time, because you can store the data, triggering the information when you store it on one of the servers. It can be immediately available on the cache, and then you can retrieve it from the other database. Okay, so these are the three elements. As I said, it depends on what you need. It depends on the fact that you need specific integration on in terms of systems, of applications, or data, and specifically for data, if you need replication in terms of real time or batch transfer or typical replication. All right. I think, yep, I finished my presentation here. Is there any question? Yes. Okay, so the question is, in the sharding architecture, how do I share information between two nodes? Well, it must be done at an application level, or you may integrate it through another level of replication. So you can basically have a replication between these elements from one main shard, basically. That's an option. Again, it depends on your solution, but you can have both. Any other question? Okay, thank you very much.